Without further ado, I'd like to introduce Ronan, who's going to talk about Docker. Thanks, mate.
Yes. Caveats at the front. I am not an expert on Docker. I've been playing with it for about a month, but it is awesome, and you should all know about it. It's a virtualization technology of sorts. Technically not true, but a very useful lie. Like a lot of things I have to say in this talk. It's compulsory I show you a giant picture of a whale with shipping containers on it. Having got that out of the way, the problem we have today is mostly with virtual machines. We use them to make repeatable environments that we can ship out, put somewhere, run up, not have any problems installing anything. But they're expensive. They take a lot of disk space, they take a lot of CPU time, a lot of memory. You've got to pre-allocate all of your memory up front. It's a stupid idea. Don't even need to describe why it's bad. And I value my battery life in the laptop more than anything else. So for me, the excess CPU usage is the worst because it hits the battery. Docker, much, much better. It runs... the Docker tool itself doesn't really run. It talks to the Linux kernel. It does all of its cool magic by talking to the Linux kernel and creates a new process group, C group. Not sure what the C means. Probably container. Which provides a little isolated area in which a process or group of processes can use some CPU, memory, whole network stack. Everything is namespaced, separated off. It doesn't know that it's running in this group. It just runs as normal. And a Docker container will typically, you don't have to, but you really should, run only the processes you need. So where a virtual machine would run a copy of Ubuntu with a logging daemon and a thing that makes sure the clock keeps ticking over, some stuff to keep a network stack rolling because it's got its own separate network stack. All of that stuff you don't need because you're already running a copy of on your host machine. You get to reuse with Docker. It's lovely. And it tries to manage resources better between the host and the guest. You get to allocate memory to the guest process. I'm going to call it a guest because this is the introduction for VM initiates, even though container's a better term. But the guest will, when it needs more memory, ask the host OS for more memory. Revolutionary idea, but VMs still haven't managed to work out a way of doing that I've found out about. Being cheap to create is a great plus point for Docker containers. Running up, creating a whole new virtual machine just to run one process, get the output, then destroy the whole thing again. It's so wasteful that you wouldn't even bother. It'd take you maybe 15 seconds to get a response back. Docker would be able to create you a whole new container, do your work, get your result out inside a quarter of a second if it's kind of laggy. And part of the way it does that is through these fast C groups in the kernel, which deal with the resource management. The other side is the disk image that it's working from, which is built on top of some kind of union file system, AUFS by default, but you can plug in others. Your image will then, as it runs, it will add new files to a layer on top of the standard image, nice and efficient like. And those layers exist all the way down to your base image. So you would have, for example, database server built on top of Ubuntu. You'd have a base Ubuntu layer. You would then have some probably compilers on top of that, and then a layer with your database software on top of that, assuming you needed to compile your database. If you didn't, those probably wouldn't get in there. But it's a nice lightweight way of doing everything you can do in a virtual machine, as long as your virtual machine was going to run Linux, which it was. Other opinions are also valid. They just happen to be wrong. So, it sounds nice. It is quite nice. It's very new. Anything that's very new, always very dangerous. You don't want to get that too close to any kind of production system, although some do, hopefully understanding the risks. Docker hit version 1.0 in June of last year. 1.0 is they think it's feature complete, apart from all of those features that keep coming up in bug reports as defects of slight bits missing. It's usable. It's a decent tool. It's fairly reliable. I'm still not going to put it into production. And because it's trying to be a lot more granular about what resources it's using, it's a lot more granular about the way you have to specify what you want it to do. It provides you with a lot of power, but you've got to learn how to use it. And if you go in trying to brute force this thing into being another virtual machine, then you're just going to throw away all the benefits and end up swearing at your tooling. So I'd advise not doing that. Those are a few things that you've got to learn new ways of doing, because starting a shell, connecting up machines, those are all easy if you've got a machine. When you haven't got a real machine to deal with, you've got to learn new ways of dealing with it. Then, I've got a duplicate slide. Lovely. There's a list of other bits of code, software that will be useful to you. You can automate use of Docker, you can compose containers together, and you can orchestrate large numbers of them. I'm assuming if you're interested and up to it, you will look at that on your own. I encourage you to. Some really cool stuff out there. These are your basic requirements, if you want it. Linux 3.8 kernel, 3.10 really, it says so on the Docker website. That's all I know about that. You can run it on Windows and Mac as well. It's all built on Linux kernel features, but it runs very well inside a VM, and boot to Docker is that VM. It has its flaws, occasionally falls over and needs restarting, but I've restarted processes before. It seems to be fine after that. And the website will guide you through it. So, a Docker container, hang on, if I click, no, never mind. I had some notes prepared that would tell me what I was about to say. And unfortunately, I cannot drive a Mac to save my life, so I'm not going to get to read those. So I'm just going to have to do this all off the top of my head again. When you create a Docker container, you create it by running a process. And Docker will then set up the appropriate environment to run it in. So if you say, run PSQL in a Postgres container, it will start a new container with its own network stack, its own process handles, all of those things. The file system, root file system, will be based off your Postgres image. And it will then create a new layer on top of that, which it will write any changes to the file system into. And the common image thing is very important. Good space-saving technique, and helps several copies of the same machine keep the same data available in memory, cached, nice and available. These containers have no visibility of each other, except for that which you explicitly provide. There is big sturdy wall built up between this container and everything outside it. It only has outgoing internet access through your host, and no ports are exposed at all. There is no access to the host file system unless you break through the security wall. And it cannot run any privileged instructions inside your kernel unless you break through that wall as well. These are all things you can do and you shouldn't, because it's isolated for a reason. There are good ways of getting through the isolation and bad ways. And the bad ways normally involve typing in --force or --do this stupid thing. Or what was it? Privileged. Privileged is something you want to stay away from when you're running Docker. Yes. Next slide. Some code. Starts to get exciting. A couple of Docker commands. When you start using it, you say, it'll help if I don't whack the screen. You tell Docker to run something. In this case, I am naming a container Ubuntu and saying run bash in it. That'll start bash shell inside Ubuntu. And there's a couple of weird flags in the middle. RM means that when I'm done with this container, I don't want it anymore. By default, that extra layer, that extra file system layer on top of Ubuntu would be preserved. And when I shut down this container, it just stays on the disk until I go and find it and delete it. And I can't be bothered doing any of that kind of thing. And you can do the similar sort of thing in CentOS. Also with the flag saying at an interactive terminal, as opposed to a daemon process. I am so much in the habit of specifying which one of those I want that I couldn't actually tell you which is the default. Again, I'm sure you can find that out if you feel particularly inclined. Sorry? Interactive is the default. But without a terminal? Yeah. Does anyone ever want that?
Not that I've ever known.
Yeah. Good knowledge. Thank you. So, that's just a toy example. It doesn't really make it look very useful at all, but does demonstrate that it's quite easy. One thing I will highlight is that there is a service called the Docker Hub, where you can retrieve images by name. And that's wired into the Docker command line process, even the run command. So when you say run a shell in Ubuntu, if it doesn't have Ubuntu, it'll go and get it. Same with a lot of other things, including CentOS and Postgres. And I was going to talk about naming containers as well. If you're going to create networks of containers talking together, you need to name them. It's not a complicated concept. You can build your own images. It'd be pretty rubbish if you couldn't. You can you build your images by starting from a base image, making some changes to it in a layer or a number of layers on top of that file system, and then you save that as a new image. And the changes are specified as a number of shell commands, and the image is specified as a name, as we saw before. You can also wrap up inside the image a few bits of metadata, like some environment variables. You can give it the command to run when you just say run, so that I don't need to type in run Ubuntu bash or whatever. In instances like Postgres, the startup command gets really annoying, and I can't remember what it is. You just run Postgres, it's fine. Hooray, I broke it. This was supposed to be a Hello World program. How about Hello Projector? Hey, magic incantations everywhere. This is a really simple Docker container, so simple as to be really stupid. What it will do is print out "Hello World" when you run it. You can see a command down here to build it, where when you build it, you've got to tag it with a name, otherwise you can't start it again. This is all. I've just caught myself reading through slides and just pointing at them, saying, this says that, and realized that I hadn't actually done the 2 minutes of introduction, which was supposed to cover that. When I started trying to learn Docker, I found there were lots of websites with pretty pictures that explained what containers do under the bonnet, and nothing that would link that up with the command line that you needed to type in to make it work. And I've tried to gather together enough to give people a quick start. I've tried to avoid technical detail as much as possible so as not to scare everyone off. Hopefully a few devs will try this as a result. So these steps should take you towards building something that is something of use to you. So everything down to this point goes in a file called Docker file. Then at the shell, you say Docker build, tagged hello world, current directory. There is a dot there. That'll tick away for a bit, build an image, then you can run that image using the familiar incantation. And you can override environment variables at the command line. And then there's a slightly more complicated version of the same thing, which actually uses run. You can run a few shell commands, in this case installing Python. You get very good at learning all of the command line flags that will install things without prompting you. Are you sure you want to install that? Just do it. I'm beginning to think we really need a globally recognized environment variable for just install the damn thing. But that's a Python version, and it'll print hello world. Doing it again, I'm going to step away from the screen and point to it from the front. Built in the same way, run in the same way. You don't really... The commands for building the container, running the container, don't really care what's inside the container, which is kind of the objective. It's good to see that. And then, because whenever you're demonstrating a new technology, you have to demonstrate how to do a web app in it, there's one. It's Python again, a couple of lines of Python to make a web server, which is then exposed to the outside world. As far as the container is aware, it's running on port 80. It says 80 over there. And then the Docker container will map that to port 8001 on the host. You can then go to your Docker host, port 8001, and talk to this container. That's how you start to connect it up with the outside world. Then just connecting one running process up with the outside world doesn't really seem that productive so far. So we're going to start connecting things up with other containers. Throwing in a few new commands while we're at it. Restart always. I think I always want Postgres to restart. The only thing I've observed that doing is making the process come back whenever I restart boot to Docker, which is useful. Haven't really cared too much about what else it does because it doesn't get in my way. Despite all of the extra parameters that you have to type in to get Docker to do what you want, it does a good job at keeping out of your way once you've run the process. Once you've run this process, it will sit there running on your system forever. You will have a Postgres database forever. That was how I got a running Squid proxy server on my laptop, so that when I'm trying to rebuild Docker images time and time again on the train, it doesn't eat through my mobile data allowance. And all I had to type for that was docker run -d squid. And I think I had to expose a port as well. Really simple, just to bring in a new piece of software you haven't worked out how to install, run it in a very lightweight fashion. no more expensive than running a process on that one VM. Anyway, short aside in the middle of another explanation. Here we can run a Postgres database server and a copy of MediaWiki. In this case, MediaWiki is linked to Postgres, except MediaWiki thinks it's called DB. And that's the name of a user-contributed MediaWiki installation. These are all working commands, by the way. If you type in just those two commands, you will get a working MediaWiki installation. The link command is particularly interesting to me. It works by connecting up the network stacks of two Docker containers, specifically connecting the exposed ports on one, declared in the Docker file. Those are exposed to the linked container, and the linked container will then be able to ping that name. The name DB gets poked into the host's file, so you don't need to care about what its IP address is. It's a great way of solving the discovery problem in more of a dependency injection sort of way. Always a cleaner way of solving that problem. So, this container is set up to expect a machine to exist called DB. And suddenly it does, and everything starts working. And that's how containers get linked. Those are most of the things you need to know about to start doing something interesting with Docker. After that, there's a few other bits and pieces. You can run a shell on something that's already running. Assuming you've got your database server running, same as the last slide, you can run a shell on it in many different ways. Well, the last one's just a bash shell. These are Postgres shells. This command will run a new container, one that we don't want to keep, but will be interactive. It'll be linked to our Postgres database, and it will be based on a Postgres image. And we will start by running PSQL, talking to the DB host, which we link to over there, as the user Postgres, and that'll drop you in running Postgres. Docker exec, that'll run exactly the same thing, pretty much, except it runs it inside the same process group. We have a named Postgres process group over here. I should have given it a different name, one that doesn't match the container. That would have been clearer. I encourage you to try experimenting with all of these commands and change all of the names. But this will run PSQL inside the same process group, where host will default to localhost, so you don't need to link up any of that stuff. And you can run bash inside the same container as well. That bash will have access to the same root file system, the same isolated network stack, all inside the same process group. I often like to throw out the lie that it's like a single process kind of virtualization. It's not technically true, but it's a good way of thinking about it. Think about the one service you're trying to run, and everything else spawns off that. And that was about all I had prepared. Seem to have got through that very quickly. Any questions? I've got another picture of a whale covered in shipping containers. It's compulsory. I sensed one coming.
Can you parameterize your Docker files? So can you chuck parameters in at the point where you run it?
You can. You can do that with environment variables. Environment variables will... you can plug them into the command. You can plug them into other environment variables. I don't think they work on port exposures. The very worst case, you can parameterize them by building a Docker container that expects a config file, and then have a number of new containers derived from that image, which provide a config file of their own, and poke parameters in that way. If you are authenticating to run Docker commands, you're logging into the shell. If you're authenticating against the application running inside Docker, then that's another process. That's presumably MediaWiki supports users. It'd be pretty rubbish if it didn't. That's got its own database, its own user framework, and passwords in there. The Postgres port itself, there is no password on the Postgres superuser. The Postgres port was never exposed to the outside world. Postgres port was only ever exposed to this one container. So this container here is running Postgres. It is listening on port, which is exposed to this container, and nothing else. It's happily sitting there listening behind a firewall. No one's going to connect. Does that answer your question?
I thought it might inherit from the VM that was running it.
It does, to the extent if you firewall that VM, you firewall Docker, but not really in any useful interactive sense.
When you said about expanding the memory,
Expanding the memory.
normally virtual servers have a restricted area of memory, so they can't just expand and.
Yes, this doesn't have that.
Right.
There's no restriction. You're running it as if it was a process on the host.
So it's not really sandboxed in the classic sense.
Sorry?
I think you said a quota, can't you? But it's a Linux thing.
Yes, I believe there are some quotas. That's about the extent of my knowledge. I believe that is.
As part of the underlying C groups, you can assign policies and restrictions for I/O, memory, CPU utilization, etc.
Cool. Do you know how?
Via C groups.
There's a command. I'm going to go have a look at that.
I think it's a -nxc dot C group, which is
Off the top of his head.
This is brilliant. I'm learning loads of things.
Sorry, you've been trying to ask.
Yeah.
Sorry, I interrupted.
How would you then, so that Postgres container,
Yeah.
inside that container are the database files somewhere.
Yep.
So Postgres 9.4 comes out. How do you update it?
Yes. It is possible. Docker does provide a few things to help you. Intentionally left out of this, figuring that people like you would look it up for yourself. Volumes are what you're looking for. Volumes are like separately mounted file systems that are tied to a particular container. When you start up a new container, you can tell Docker to use the volumes from another container. So it would be quite common to start a container called Postgres data and have provide a new startup command, which is going to return immediately, make it an echo. Then, because it's based on the Postgres container, it will have the Postgres volumes created. And as long as you don't delete that container, you will always have those volumes. And then when you start Postgres 9.4, you can tell it to use volumes from Postgres data. So.
How does it work with file system access then? Do containers have the ability to access limited areas of the file system, or do they have their own file systems?
They have their own root file system provided by the image. Right. It is possible to mount in parts of your host's file system, which I do a lot in development, mounting the live code base from my dev machine into that system so that it runs that code, and whenever I edit it, it gets updated inside the container. Within the container, you cannot break out into the host and pick pieces to get to. You can't go and look at the host's file on your host. unless it's been explicitly exposed.
I was just thinking when you're doing things like creating a Postgres database or something.
I would build the two into the same image. I can't. Yes, this kind of thing demonstrates it. You get to specify a command to run when you just say run this image. And you'll note that this one down here doesn't specify a command at the command line. What I would normally do is craft this command such that it would create the database if it doesn't exist and then run the application, including any database setup and populating with your first admin user or whatever, just to avoid a manual step. Because
You said you wouldn't use this in production.
Yep.
Do you see yourself using this in production in the future?
I hope so. It would be lovely to be able to trust it that much. I think for something that wasn't especially important, that I could afford to have go down for a day while I rebuilt it in a new data center on actual machines, then I might consider it. It's very efficient. Being able to throw in a new image for version 2 of your application. Say, shut down 1, bring up 2. It didn't work. Shut down 2, bring up 1. It's much better. There are so many features around it. There are bits of software like Kubernetes. That one I really want to get my head around properly. That seems to provide a system where you describe groups of containers that you want running as applications. So a database server and a pair of application servers, for example. You would group those together as one unit, then give that to Kubernetes, and on the other side it's got some cluster of machines. And it will then make this thing run on those. And you forget about the details. I love forgetting about details. No. Maybe I'm resigned to forgetting about details and I've learned to work with it. Yeah, I would really love for Docker to be something I could wholeheartedly recommend to you as a production tool, but it's not that yet. It's definitely moving in that direction, though, and it's getting some competition along the way.
I disagree. Amazon AWS is using it for companies like Netflix. It's part of Google Cloud Platform now. Linked with Kubernetes as part of Container Engine.
Yep.
It's very much hit the big time.
Yep. But that's a completely different business situation. Those companies employ the people who wrote that software.
Yeah.
That puts you in a very different position. If you can get expert advice on tap, then yeah, go ahead, deploy it. There aren't that many of those people available.
Better way of putting it, expert people on pager duty.
Yes.
But if you want to avoid, if you actually want to use Docker, then just sign up with an AWS account and it's drag and drop. You hardly need to code at all.
Yeah, I like to code. Yeah, there are lots of drag and drop tools out there. Octahost looks very interesting, and I was playing with another one earlier called Panamax, which is deployable inside a Docker container, obviously, and runs its own. It will let you browse images through a web-based UI, group them together into applications as templates, and then deploy a whole template onto a cluster somewhere, or a single host, whatever. There's a simple protocol that says run these things, so you can hide a cluster behind that. It's a piece of software that's clearly been designed with the big time in mind. But for most people, it's not ready to take there, unless you can afford to bring in the support when you need it, or to have it go down while you work it out yourself.
I'm not sure your VM analogies either.
Most analogies about VMs are unfair.
Yeah. I think the overheads you said were overestimated.
Just some On that machine, I typically run 4 different VMs with Python, Django servers running in them, and that knocks my battery life down by 60%.
If that's a development workload or a development platform, but not a production VM system.
Yeah. And I accept that that's a development workload, but a 2.5-hour battery life doesn't support much development. If I can get that back up to 8, then I'll be a much happier developer doing a whole day's work. Everyone likes that.